Hello, I'm John Accardo, Senior Applications Engineer for Siemens clamp-on Flowmeter products. After commissioning one of our clamp-on Flowmeters, we are often asked, how do I ensure my meter is operating properly and that the readings are accurate? In this program, I'm going to show you how to use a few simple diagnostic tools to validate your meter performance. All Siemens clamp-on Flowmeters have a powerful built-in diagnostic menu that you can use to learn a lot about your application and validate performance. In this program, you will learn how to confirm your liquid sonic velocity, how to verify your sensor signal strength, how to evaluate your liquid condition, and how to validate your sensor signal wave shape. In addition to your Flowmeter's diagnostics, Siemens also has an interactive software diagnostic tool called SIWare. It is available for download at no cost from our website at siemens.com/SIWare. Before we look at any meter diagnostics, I must emphasize that performance begins with you, the user. Accurate pipe dimensional data and programming entries are paramount in achieving superior accuracy from your meter. Also be sure to position the sensors at the spacing positions indicated by the meter. Evaluation of your meter operation begins once it is successfully installed. We accomplished this when we saw the meter publish your liquid sonic velocity, VS, during the installation procedure. VS is an extremely important indicator of meter performance that I will be emphasizing as we proceed. But first, we just want to initiate operation, so we can simply press the down arrow to proceed. From here, it's just a few keystrokes to access the diagnostic menu. When you arrive at the diagnostic menu, you will find that it is made up of several subcategories. We want to begin in the category Flow Data. Here you will find data that validates your liquid sonic velocity, sensor signal strength, and liquid condition. Let's begin with the signal strength. It is indicated by the parameter VALC. While signal strength is not an indicator of accuracy, it is an important value that ensures adequate operating margin and stability of the application. Without sufficient signal, it would not be sensible to proceed with the evaluation. What is a good VALC value? The VALC is influenced by many factors within the application and the installation, so there isn't one perfect number. A value of 30 or higher ensures good signal amplitude, yet values as low as 15 are suitable for good performance on many applications. Consider the condition of the pipe and viscosity of the liquid when evaluating VALC. For example, on older or poor condition pipes or high viscosity liquids, it is likely the value will be lower. What can you do if the VALC is low? If the VALC is low, it can usually be improved through one or more of the following techniques: careful recoupling of the sensors, conditioning of the pipe exterior, relocation of the sensors, mounting the sensors in direct mode, or use of max spacing offset. On this installation, the VALC is 59. So having confirmed adequate signal strength, let's revisit the sonic velocity measurement indicated by the parameter Vs. This is the same value that was presented at the conclusion of the installation process and is the key indicator of an accurately performing meter. Vs is precisely computed from the transit time measurement. Its value enables the meter to determine the refraction angle of the sonic beam in your liquid, and is therefore a fundamental part of the flow equation. What can affect sonic velocity measurement, and how can you be sure the displayed value is correct for your liquid? The main influences on sonic velocity of a fluid are its temperature and density. Let's take the example of water. Siemens has a very detailed table of water's Vs relative to temperature. Therefore, it is very easy to determine what your sonic velocity should be based on your water temperature. What if you have a different liquid? Siemens also maintains a database of many common liquids, but you might have a liquid that does not appear in it. Don't worry though, it is quite easy to validate the measured value. Vs is simply the result of a distance versus time computation. The Flowmeter can very precisely measure the time component, and we can verify the preciseness of this measurement. That leaves the distance, or in other words, dimensional portion of the equation in question. Fortunately, the dimensional values are something you have complete control over. The dimensions relate to the pipe diameter, wall thickness, and material, plus the sensor type, size, and spacing. Therefore, by ensuring the accuracy of these values when you program the meter, you eliminate any possible source of dimensional error. Now let's confirm the timing measurement, which also gives us the opportunity to evaluate another important performance indicator, our sensor signal wave shape. Let's exit the flow data category and scroll down to test facilities, where we can access graph mode. Here we can see a graphic image of our sensor signal wave shape in real time, and also verify our transit time measurement. If you look at the left side of the wave, you will see a vertical bar which marks the measured point of arrival of the signal. Identifying the position of this bar in the first wave cycle of the signal confirms the correct measurement of transit time. Couple this with ensuring the accuracy of the dimensional programming, and you are assured of a correct sonic velocity measurement. Now you have also established the sonic velocity of your product, which enables immediate verification on future installations. What else can the signal graph tell you? The signal wave shape is the heart of Siemens wide beam technology. A proper wave shape verifies the match of the sensors to the pipe, ensuring ultimate performance independent of liquid characteristics. What should you look for to confirm a good signal shape? When evaluating your signal, start from the left side of the graph. The baseline should be flat, leading up to the start of the wave. The wave shape itself should be symmetrical and reach maximum amplitude in typically 5 cycles, then begin to decrease again. Therefore, the keys to confirming an acceptable signal wave shape are a flat, quiet baseline, the placement of the timing marker, and a symmetrical shape with no evidence of anomalies or excessive cycles. What could cause a poor quality wave shape? Siemens sensors are selected by the pipe they are to be installed on. This ensures optimal matching between the sensors and pipe, producing a well-defined, stable waveform. Therefore, only a mismatch can result in a low-quality signal shape. Such a mismatch can occur if an incorrect sensor is selected or the pipe is of a different dimension than originally specified. Now that we've determined our meter has sufficient signal amplitude, correct sonic velocity, and a good signal wave shape, is there anything else that can impact system performance? The only aspect of this application we haven't fully confirmed is the liquid condition. Sometimes liquids can be aerated due to cavitating pumps or valves, or air trapped in the system, without the user being aware of its presence. Aeration will impact the accuracy of any flow meter, clamp-on or intrusive, since air occupies space in the pipe. Siemens clamp-on flow meters are excellent detectors of aeration and report it with the diagnostic parameter VAER. It can be found in the flow data menu we looked at earlier. VAER is a value between 0 and 100. Lower is better. Values less than 10 indicate insignificant amounts of aeration, while higher levels will indicate the magnitude of entrained air. In applications where aeration is significant, you will notice a decrease in signal strength proportional to increased aeration. Aeration is an undesirable property in most applications and can lead to pump and valve damage. Therefore, it is important to know if it is present. When aeration is high, you can expect a reduction in accuracy, while confirming low VAER values is the final validation of meter performance. So let's review what we've accomplished. To verify meter performance and have confidence in its readings, we must ensure adequate signal strength as reported by VALC, accurate sonic velocity measurement of the liquid through confirmation from available data or validation of transit time measurement and dimensional data, acceptable received signal wave shape and signal to noise ratio, and confirmation of low to no aeration of the liquid. Of course, if you're unsure of a diagnostic value or need assistance with your meter, live technical support is always available. You can receive assistance from a qualified field engineer at no cost by calling one of our regional support hotlines. We hope you have found this presentation valuable, and we thank you for your time and attention.